Today we're working on Chapter 3, Section 6, Absolute Value Equations. Before we get into any problems though, you've got to understand one major concept here. What I have on the screen is the absolute value of x equals 3. There are actually two solutions for x here because there's two numbers that I could plug in and make this true. X could obviously be 3 because the absolute value of 3 would be 3. But x could also be negative 3 because the absolute value of negative 3 would still be positive 3. So two solutions for the absolute value of x equals 3. Okay, so when we get into these problems, we want to get the absolute value, whatever's within the absolute value symbols, we want to get that by itself because then we can see what that's going to be equal to. Let me show you what I mean with this example. We have the absolute value of x plus 5 equals 11. Like I just said, we want to get the absolute value of x by itself because once that's by itself, I know that there's going to be two solutions to that answer. So first we need to get this 5 to the other side, and since it's a plus 5, we'll subtract 5. So we have the absolute value of x, these cancel, is equal to 6. That way we can see that x could either be 6 or it could be negative 6 because I could plug either one of those in and it'll make that a true statement. And now to check our work, let's make sure we're correct. We think that it's either 6 or negative 6. So the absolute value of 6, let's try that one first. This would obviously be 6, and 6 plus 5 is 11, and that's equal to 11. Over here, let's try negative 6 now. The absolute value of negative 6 plus 5, we want to see if that's equal to 11. This would be 6, and then 6 plus 5 is 11, so that's correct. All right, let's make it a little harder now. Now we've got 4 equals 3 times the absolute value of w minus 2. So separate our two sides. Remember, we want to get whatever's within that absolute value symbol, we want to get that by itself. So it's just the w now. We want to move the 3 and the 2, but just like when we're undoing equations, you want to undo addition or subtraction first. Therefore, we need to move the minus 2 by adding 2 to both sides. So 4 plus 2 is 6. Bring this down the way that it appears, and these cancel. Remember that absolute value symbols, while they're not the same as parentheses, they act as parentheses in terms of it meaning 3 times w, so that's multiplication, so we want to divide by 3 on both sides. So this would be 2. These cancel, and we get the absolute value of w by itself. Now that it's by itself, we know that w can either equal 2 or it could equal negative 2. And let's check that to be sure. 4 equals 3 times the absolute value of 2 minus 2. First let's do the absolute value. This would be 3 times 2 because the absolute value of 2 is 2. And then this is 6. 6 minus 2 is 4. Over here we have 4. Those are equal, so that's correct. Now let's try negative 2 here. So 4 equals 3 times the absolute value of negative 2 minus 2. This is still positive 2 because the absolute value of negative 2 is positive 2. And this would be 6 minus 2 would be 4, and that's equal to 4, so that's correct. All right, now what if in the last two examples we had just the x in the absolute value symbols, and in this example we had just the w in absolute value symbols? What if we have the whole sentence in absolute value symbols? The absolute value of 2p plus 5 equals 11. Here, remember I told you before, you want to get whatever's in the absolute value symbols by itself. It's already by itself. This is all in absolute value symbols. So what that means is the absolute value of 2p plus 5 could equal 11, or 2p plus 5 could equal negative 11. Because imagine if that was just a p. Remember, if it was just p, the absolute value of p equals 11. We know that p could either be positive 11 or negative 11. Well, now instead of just having p, we have the entire expression. So 2p plus 5 could be positive 11 or it could be negative 11. Let me erase this so you don't get confused. So now really they're easy equations to solve, but what we have is we have two separate problems that we need to solve in order to figure out what p can be, because remember it can have two solutions. So over here we'll separate the two sides, undo addition with subtraction. These cancel, so we have 2p equals 6, and then we need to divide by 2. So we get p equals 3. Now we have to solve the other equation. So separate the two sides, undo addition with subtraction. Bring down the 2p, these cancel, and then negative 11 minus 5 is negative 16. Divide by 2 again, and we get p equals negative 8. What that means is if we plug in either of these solutions, it should make a true statement. So let's prove it and check it. We think p is 3 or negative 8. So I have that here. So first we'll take the absolute value of 2p. Oops, I want to plug that in though. Let me erase that. We want to do the absolute value of 2 times 3 plus 5. We want to see if that's equal to 11. So first we have to solve what's in the absolute value symbols, and within there we have multiplication and addition, so we need to do the multiplication first. Keep my absolute value sign, so that's 6. And then 6 plus 5 is 11. And the absolute value of 11 is 11. And over here obviously we still have 11, we can't do anything, so I just brought that down. So the 3 works. Now let's try the negative 8. The absolute value, let me change color so you don't get confused. The absolute value of 2 times negative 8 plus 5, I want to see if that equals 11. So here keep your signs, the absolute value signs. 2 times negative 8 is negative 16, and then plus 5 would be negative 11. The absolute value of negative 11 is still positive 11, and that's equal to 11, so that's correct. All right, let's put everything together now, everything that we know. So here we have 2 times the absolute value of d plus 3 equals 8. The absolute value symbols are not by themselves yet, so we need to get this 2 away. And remember, it's attached with multiplication, so we're going to divide by 2 so that the absolute value symbol's by itself. This way we have the absolute value of d plus 3 is equal to 4. Now I know that d plus 3 can either be positive 4 or d plus 3 can be negative 4. So let's solve this. We separate our two sides, subtract 3. So d is 1, or subtract 3 here, d is negative 7. Both of these are solutions. And again, let's double check 1 and negative 7. So let's try the negative 7 first. We have 2 times the absolute value of negative 7 plus 3. And I want to see if that equals 8. Remember, absolute value symbols act like parentheses, so we need to do this first. So 2 times, this would be negative 4. Now we need to take the absolute value of this before I multiply it by 2. So 2 times the absolute value of negative 4 is 4, and that would be 8. This is still 8, so those are equal. Let me change colors. Now we want to try positive 1. So 2 times the absolute value of 1 plus 3. I want to see if that equals 8. So 2 times 4. And then the absolute value of 4 is still 4. That would be 8, and that's equal to 8, so that's correct. My answer is D equals negative 7 or 1. Okay, one more example like this. Negative 3 times the quantity y, negative 3 times the absolute value of y minus 3 equals 9. The absolute value is not by itself yet, so we need to get that negative 3 away from it so it's by itself. So separate your two sides and divide by negative 3. These cancel, so we have the absolute value of y minus 3 equals negative 3. All right, here's where we need to stop. This problem cannot be solved. There is no solution. That's what you would write for your answer. No solution for this problem, because think about it for a second. Can the absolute value of anything equal a negative? No. So no matter what I plug in here for y, nothing can make this possible because it's got to equal negative 3. And the absolute value of anything is not going to equal negative, so that means that there's no solution to this problem. All right, that's it for today. Bye, guys.